Harold Ipsen, born in 1915, grew up in Rockford, Illinois. His father, Mogins, was an engineer for the city and head of the Depression-era Rockford Works Progress Administration. Following in his father's footsteps, Harold earned a degree in engineering from Brown University. 1 year later, he established a traditional heat-treating business, which he named Ipsen Industries. During World War II, Ipsen secured multiple government contracts as a supplier of artillery shell components. After the war, Harold married Lorraine Roble, who owned and operated a decorative pottery business. When her kiln broke down, Harold decided to design and build a new and better kiln himself. He later realized the high-performance features of the new pottery kiln could also be applied to the parts processed by his heat-treating business. After additional development work, Ipsen reincorporated as a manufacturer of heat-treating furnaces on July 1, 1948. Within a few years, Ipsen was a recognized pioneer in the heat-treating industry, offering furnaces which promised more uniform metallurgical results, greater production capacity, and lower operating costs. By the late 50s, having already created its Ipsen Ceramics division for materials development and Ipsen Lab for metallurgical research, Ipsen was setting its sights on growth outside the US. They first expanded to Canada, then later to Germany, where Ipsen furnaces supported West Germany's steel industry in the Ruhr Valley. By this point, Ipsen furnaces were used in the manufacturing process of everything from typewriters and washing machines to automobiles and airplanes. In the post-war era, technology was becoming a part of everyday life, and heat treatment was a key part of producing almost anything made of steel. To accommodate its ongoing growth, near the end of the decade, Ipsen opened a new facility in Cherry Valley, Illinois, where its U.S. headquarters still operate today. During the early 1960s, the Cold War and space race drove further innovation. In addition to its traditional products, Ipsen developed more sophisticated furnaces for the production of missiles, space probes, advanced aircraft, and rockets. The Ceramics division was producing materials for the government's nuclear energy and defense programs, and Ipsen Lab was working with NASA to study exotic metal foam applications in spacecraft. Business was booming. Late one evening, in the spring of 1965, Harold Ipsen died on impact as the private plane he was piloting attempted to land at the Greater Rockford Airport. He was 49 years old and left behind a wife, 3 children, 30 patents, and a legacy as the most innovative heat treater of his era. Under new ownership, but consistent with its history of product development, Ipsen introduced the first bottom-loading vacuum furnace in 1966, the Metal Master Furnace in 1967, and the Vacuum Oil Quench Furnace in 1968. During the 1970s, Ipsen innovation continued. Batch and continuous vacuum aluminum brazing furnaces were developed, diffusion bonding and ion nitriding furnaces were introduced, and the first vacuum tempering furnace was sold. Ipsen wrapped up the decade by receiving its largest order to date, when a Polish steel company purchased 10 horizontal vacuum furnaces. The 1980s began slowly, with an economic recession, high interest rates, and an accelerating shift in the U.S. market from manufacturing to service. Still, promising new technologies were emerging, and the 80s introduced us to stealth aircraft, the first space shuttle launch, cell phones, and dramatic advancements in personal computers. In 1985, Ipsen merged with competitor ABAR, becoming ABAR Ipsen Industries. The consolidated companies continued to innovate, and during the last half of the decade, released the world's first 5-bar vacuum furnace, the all-new turbo treater, and the invention of the Ivodizer, which replaced environmentally toxic cadmium plating with aluminum vapor deposition. The 1990s saw continued economic growth, marked by significant advancements in telecommunications and computing. With a focus on international expansion, Ipsen opened multiple sales and service locations around the world, as well as a manufacturing plant in Shanghai, China, to support the growing customer base in Asia. Back in the US, Ipsen established strong partnerships with customers such as Boeing, Caterpillar, and Chrysler. After a successful decade of assimilation, ABAR Ipsen Industries became Ipsen Incorporated. Ipsen started the new millennium with a reinvigorated focus on growth and innovation. The global VR furnace was launched early in the decade, and software upgrades enabled better service and connectivity to customers via the internet. In what was a new, largest ever order, John Deere Waterloo chose Ipsen to supply furnaces for their massive new drivetrain shafts and gears program. Ipsen then acquired Vacuum Furnace Systems Corporation in Souderton, Pennsylvania, expanding its staff and facility to increase hot zone production. Extending its global reach even further, new plants in Japan and India were opened. Finally, and arguably most significant, Ipsen attracted the attention of heat treaters everywhere with the 2009 launch of its new from-the-ground-up Titan furnace, a high-quality platform product, a better, faster, and higher-value furnace built to global standards with a smaller footprint, quicker delivery, lower cost, and easier installation. Still going strong almost 15 years later. The 2010s witnessed an acceleration of private space exploration, as well as electric vehicle production. Manufacturers placed more importance on adopting sustainable business practices and improving processes to minimize waste and lower operating costs. During this decade, Ipsen ramped up development and sales of furnaces for customers in the growing additive manufacturing industry and introduced PD Metrics, a groundbreaking predictive maintenance software. Then, 2020 and the global pandemic. Ipsen tenaciously supports its customers, especially those in critical industries such as medical, transportation, food and beverage, energy, aerospace, and defense. Ipsen also used this time to reorganize and optimize its business structure, improving efficiency, becoming more responsive, and consolidating manufacturing. Today, the Vacuum Technology Excellence Center in the U.S. and the Atmosphere Technology Excellence Center in Germany enable faster-paced innovation and a laser focus on performance and quality. Looking ahead, we see a future filled with opportunity. Ipsen is committed to embracing digital transformation, sustainability, and expanding customer service offerings to ensure that their legacy of success and innovation endures for years to come. Thank you for making the last 75 years possible.